This is the Tregro model interface. This main screen serves as a main menu. These icons are buttons that will allow you to navigate the interface or perform various functions. Right now, I'm going to visit the overview and documentation part of the interface by clicking on this button. These buttons allow you to view various documentation sections. Right now, we're going to look at processes in Tregro. The Tregro model revolves around three main cycles. Those are water, carbon, and nutrients. Right now, we'll look at the water cycle in detail by clicking on this button. The water budget model predicts canopy retention and throughfall, soil infiltration, evaporation, distribution, and drainage, plant water uptake, and finally, transpiration. Now we'll look at the carbon cycle. Photosynthesis depends on environmental factors, plant nutrient status, and total leaf mass. Newly fixed carbon is allocated first to respiration, then growth, and finally storage of excess. Partitioning among plant compartments is influenced by the time of year and nutrient pool size. Storage pools may be mobilized for respiration or growth needs. Carbon may be lost through lithophall and root senescence. Now the nutrient cycle. Nutrients available for plant uptake are calculated on a daily basis. Elements enter fine roots through active uptake and/or bulk water flow. Nutrients are stored and used for growth. Lithophall and root senescence return some elements to the soil. Now we'll see the daily cycle in the model. During one simulated day, the tree maintains an internal plant nutrient pool. First, newly fixed carbon is calculated. Above ground growth is then calculated. After above ground growth, nutrient uptake is calculated. And finally, below ground growth. In this case, below ground growth was carbon limited. This is another example of a day. In this case, it's nutrient limiting conditions. Again, carbon is calculated first. And above ground growth takes place, but this time above ground growth is limited by nutrients. The nutrient pool is replenished and below ground growth takes place. In this case, there was more below ground growth. We'll go back to the main screen of the interface. By clicking on this next button, we can see how input parameters are changed. This screen allows you to change the starting and ending days of a model run. Here you can enter the name of an input parameter file, and by clicking this button we can go to other screens that allow us to change parameters. These different buttons represent different categories of parameters that can be modified. Right now we'll look at photosynthesis parameters. Sometimes variables can be entered directly in fields, and other times there are other buttons to take us to different screens. For example, this leaf water potential effect, where we can change slope and thresholds of this curve. Right now, I'm going to turn on ozone effects on photosynthesis. By clicking this button, we can have ozone affect mesophyll conductance. This effect is shown in the screen. Where we can enter a threshold and a slope of an effect of mesophyll conductance versus cumulative ozone dose. Also, we can increase the ozone level from ambient to twice ambient by entering a 2. At this point, by clicking on this button, we could start a model run. At this point, we'll look at some output of model runs that have been done. I'm going to open a file that represents a 3-year base run. What we see here is a bar graph representing different carbon components of the tree. This control panel allows us to view different days within this 3-year run. For example, this is April 18th in the first year. By sliding this pointer ahead, we can jump to, in this case, August 28th of the second year. The white part of these bars represents the TNC. This solid color represents living structural tissue. And finally, this patterned part of the bar represents non-living or wood tissue. Also, rather in this bar graph, we can look at a graphical representation of the tree. In this representation, the size of these compartments represents the amount of carbon within those compartments. We also show total cumulative photosynthesis and cumulative respiration. We can also open other files for comparison. I'm going to open a 3-year run with twice ambient ozone. If I jump ahead to the end of the model run, you can see immediately that there was a difference between the base run and the ozone affected run. We can also animate a sequence of days and view that animation later on. I'm going to open an animation that was made previously. So this is early in the first year. We can see that there's very little difference in the trees at this point. We're now in the second year. The cumulative photosynthesis and respiration have been reset. Now we're beginning to see visible differences between the base run and the ozone affected run. And in the third year, again we can see differences, especially in the below ground mass. Finally, we can run through this animation again, and that'll take us to the end of our presentation.